Greetings, grade 10s. Let's look at some problems. How do we use trigonometric ratios to solve some problems? Okay. Right, let's say you are given a triangle ACD and it has got a line in it, line B, and then you are asked to complete. First of all, find AC, find AD, find BE, find CD, find cos A in triangle ABE, and find tan C in triangle ACD. Right. So I hope you pause and then try to attempt those questions and then press play to see if you can get it. So if you look at AC, so that one is a simple one. AC will be equals to AB plus BC, and then AB is 5 units and BC is 5 units. So AC will be equals to 10 units. And then AD is equals to AE plus ED, right? And then AD will be equals to 3 plus 5, which will be equals to 8 units. And then BE, so to find BE, we are going to use Pythagoras. And Pythagoras tells us that BE squared will be equals to AB AD squared minus, right, so it's going to be AB squared minus AE squared, which will be equals to square root of 5 squared minus 3 squared, which will be our BE will be equals to 4 units. And then CD, we see that CD is going to be equals to AC square root of AC squared minus AD squared, which is Pythagoras. So we substitute the values. It's going to be square root of 10 squared minus 8 squared, which is 6. And then in a triangle ABE, find cos A. So cos A is going to be adjacent over hypotenuse. So our adjacent in this is 3 units and our hypotenuse is 5. So that will give us 0, that will give us 0. So this will give us 0,6 as a ratio. And then moving on, tan C will be equals to opposite all over adjacent. So in this case, our opposite in triangle ACD with reference to angle C will be CD, which is, we calculated it. Remember, opposite, which is AD, which is 8 units, all over adjacent, which is CD, which is 6 units, which will give us 4 all over 3. I hope you got that one correct. So that one, let's look at another example. Right, you are given a triangle EFGH, and the triangle has got that information. And then they say do not use Pythagoras, right? So you can use anything else. Determine A angle of FEN, and then B angle of FHG, and C, right? So you are given those. Find FE, that is C. So I hope you pause and you attempt, and then after you're done, you can press play so that you can confirm your answers. So for angle FEH, if you look at angle FEH, right, you see that we can use either of the triangles. You can use either triangle EGH or triangle EFH. which will give you the answer. So if I use the triangle EFH, I'm going to say sine of angle FEH will be 12 all over 20, which is opposite all over hypotenuse. And then you can now make FEH subject to the formula. So we are going to get FEH will be equals to arc sine of 12 all over 20. Punch, you can take a calculator and you can punch that into a calculator, and then you round off to 2 decimal places. That will be 36,87 degrees to 2 decimal places. And then angle, so you can use the other triangle, you must arrive at the same answer. And then angle FGH, so that one you can use sum of angles in a triangle, right? And then you can easily find the size of FHG, right? Or you can use, since that one, you can say 90 minus the angle FEH, and then you can find the angle FHG. But here you see myself, I'm going to use a trig ratio. I'm going to say cos of FHG is equals to 12 all over 15, and then FHG will be equals to arc cos of 15 all over 12 all over 15, which gives me 56.87 degrees. Okay, moving on, let's find FE. Remember, they say don't use Pythagoras, so we are not going to use Pythagoras. We have to use the trig ratios. We are going to say cos of theta is equals to FE all over EH, and then we make EH subject, FE subject of the formula. We multiply both sides by EH, make FH subject of the formula, and we make FE subject of the formula, and then our FE will be equals to 20 cos 36,87. So you punch that into a calculator, and depending on the question, in this case you see I'm rounding off to 2 decimal places, which gives me 16 units exactly. Right, rounded off to 2 decimal places. Moving on, another example. You are given a quadrilateral, right? And then you are given the quadrilateral has got information, and then they say calculate. And then you see, there we go, you are given the vertices, and then they say calculate AC, calculate AD, calculate DC, and calculate the area of ABCD, the quadrilateral. Right, so pause and attempt it, and then you press play to see if you can get it. So let's play. Calculate AC. How do we calculate AC? AC will be equals to AB squared plus BC squared, which is Pythagoras. And then we substitute the values, we get the answer. Right. And then AD again. Now that we've got AC and ACD is a right angled triangle, we can use Pythagoras. Here they did not say don't use it, so we use it. So we're going to use Pythagoras. It's going to be cos 42 degrees, right, will be equals to AD all over 5. And then we make AD subject of the formula. We solve for AD. It's going to be AD will be equals to 5 cos of 42 degrees, right? And then you take your calculator, you punch that into a calculator, you get 3,72. This is to 2 decimal places. Now going to DC, now we've got AC, and now to calculate DC, we are going to use the relationship between AC and AD and the angle 42. So that one will be cos Pythagoras. DC, we can calculate DC using Pythagoras. So because we've got the side AB and side BC already, we can use Pythagoras for that. Right, so there we go. We can use that one. Yes, there we go. And DC would be equals to 3,34. to 2 decimal places. Right. After doing those calculations, now they say calculate the area of this of ABC. So we can, to calculate that area of ABCD, we are going to say area of triangle ABC plus the area of triangle ACD, and then we know that it's half base times height. So here our base will be AB, height is BC, and for ACD, base is AD and height is CD. Then you substitute the numerical values, and then we simplify. Our answer will be equals to 12,21. This is to 2 decimal places. So please try some questions, right? Try some questions so that you do practice. Okay.